So here in this video we'll start with exercise 7.3, the 16th question. Okay, so here in my previous video I would have finished till the 15th one. So here the 16th one, integral of tan power 4x dx. So I told you we'll be using the substitution method, but before the substitution method, we must know how to simplify it by using the trigonometric identities. So what are the trigonometric identities you have here? Tan power 4x dx, which is equal to tan squared x the whole square dx you have here. So first I'm going to simplify this and write. So it's nothing but I've written it as tan squared x into tan squared x. In spite of writing it as it is, I cannot again use a substitution part. So what I'm going to do here is, that differentiation of tan is secant squared. So I can write this tan squared as secant squared x minus 1 into tan squared x I can write here. Now you multiply it. When you multiply it, what will you get? Secant squared tan squared x minus what will I have here? It's nothing but tan squared x dx. Got it? So here you're left with integral of secant squared into tan squared x minus integral of tan squared x dx. This is what you have here. So what have you got? It's integral of secant squared into tan squared x minus, again use the trigonometric identity here, integral of secant squared x minus 1. So this integrand, to integrate it, I will not have an issue because integral of secant squared is what? Tan. Integral of minus 1 is nothing but minus x. But here I need to know how to integrate it. So what is the possibility here? Differentiation of tan will give you nothing but secant squared. So here we'll just do it like that. So what will I do here? Put t is equal to tan x. So when I put t is equal to tan x, you will get dt by dx is equal to secant squared x. So what is your dx equal to there? It is equal to dt divided by secant squared x you get here. So what is your I equal to? I equal to integral of secant squared x. Okay, so here in this case, what is your t equal to here? T is nothing but t squared you get here into dt divided by secant squared x. So here again, if you see, it gets cancelled in this case. So as I told you earlier, integration of secant squared x will give you what? Actually it's nothing but tan x minus integral of this will give you nothing but minus x. So minus of tan x minus x. So the second part I have integrated. Now here you are left with what? Actually your t squared dt minus tan x plus constant. So what is integral of t squared? It's nothing but t cube divided by 3 minus tan x plus a constant. What's the value of t equal to there? T is equal to tan cube x by 3 minus tan x plus a constant. Is it clear? Okay. Now the 17th question you have, integral of sine cube x plus cos cube x divided by sine squared x cos squared x. So here if you see, this one advantage here, in the numerator you have plus, in the denominator you have product, and moreover the numerator and the denominator you have only sine and cos. So there's a possibility for us to split it like this. Okay, so split it as two different rational functions here. So when I write it as I equal to integral of sine cube x divided by sine squared x into cos squared x plus integral of cos cube x divided by sine squared x into cos squared x. So we'll see how we can integrate this part. Here I've just carried forward that here I've just rewritten in this case, it's integral of sine cube by sine squared x into cos squared x plus cos cube x divided by sine squared x into cos squared x. So here if you see, this gets cancelled here. Okay, so in that case you're left with sin x divided by cos squared x plus here again if you see, this cos cube and this cos squared, it gets cancelled. So you're left with cos x divided by sin squared x. So I've just written it as two separate integrals here. Integral of sin x divided by, this can be written as cos x into cos x dx plus integral of, here if you see, you have it as cos x by sin x into sin x dx. Now what is sin by cos here? It's nothing but tan. What is 1 by cos? That's nothing but secant x dx plus integral of cos by sin. What is cos by sin? What will you get here? It is cot x. What is 1 by sin here? It's nothing but equal to cosecant x dx. So what is integral of tan x secant x here? That's nothing but secant x minus okay, so here why I have written minus? Because integral of cot x secant x. What is integral of cot x secant x? That's nothing but equal to minus cosecant x plus a constant. Okay. Now the 18th question you have here. So what's the 18th one? Integral of cos 2x plus 2 sin squared x divided by cos squared x. So here if you see, I cannot split it as it is. I'll tell you why. Because here I have cos 2x, here you have cos squared x. This I can split, not a problem here. So what is the formula I can write in this case actually? What is it? You know that your sine squared x is equal to 1 minus cos 2x divided by 2 here. So when I cross multiply, you will have it as 2 sine squared x is equal to 1 minus cos 2x you get here. Taking it to the other side, what will happen actually here? You will get it as cos 2x is equal to 1 minus 2 sine squared x. This is what you have here. So here this cos 2x, I have written it as 1 minus 2 sine squared x. Here you have plus 2 sine squared x. You may think that why is it I am not using cos squared x equal to 1 plus cos 2x by 2. If I use 1 plus cos 2x, I will have it as cos squared x. Cos squared x, if you see here, it's not of much use for me here. That's why I write it as 1 minus 2 sine squared x plus 2 sine squared x. When I write it here, what will happen? This gets cancelled. So you're left with integral of 1 by cos squared x. So what is integral of 1 by cos squared x? That's nothing but secant squared x dx. So integral of this will give you nothing but tan x dx. Okay. Now here the 19th question. Integral of 1 by sin x into cos cube x dx. So what is integral of sin x by cos cube x dx? What will I have? It is equal to integral of 1 by. So here again, if you see, you have got cos cube. Even if it goes to the numerator, you will have it as secant cube x only you have here. This is nothing but cosecant. So I cannot do much with secant cube. And moreover, always remember, if you have an even power, it is easy for me to apply the identity here, because you know what is secant squared x only you know here. So it's easy for me to apply the identity or the differentiation formula also. So here what I'm going to do is I'll multiply and divide by cos. So I'll have it as sin x by cos x. Here when I multiply, already you have cos cube into cos will give me what? Cos power 4x. What is 1 by cos power 4x? That's nothing but secant power 4x divided by sin by cos will give you what? Tan x dx. This is what you have here. Okay. Now here, so I hope you understood here. First of all, I am just making it to an even power in that case, because we know even if I want to use substitution, you know your differentiation of tan x is equal to secant squared x. Otherwise, if I want to write secant squared or x also, I can write it as 1 plus tan squared x. That's the reason. Okay. Now see how what we proceed here. This one I have just written it as secant squared x into secant squared x by tan x dx you have here. Now this one I will write it using the identity 1 plus tan squared x into secant squared x by tan x. So here if you see in this case, I already told you by the method of substitution, if you differentiate anything, see if you get something else. Yes. So when I differentiate tan x, what will you get? You will have it as secant squared x. That's nothing but in the numerator. So when your secant squared x get eliminated, you will get the whole function in terms of t. So your t is nothing but equal to tan x. So it is easy for me to integrate it. So what is the substitution I have put here? Put t equal to tan x. You will get dt by dx is equal to secant squared x. What is your dx equal to? Dt divided by secant squared x you get. So your I equal to integral of 1 plus t squared, because here if you see, your t is nothing but tan x. I have just substituted 1 plus t squared divided by t, and here you have it as secant squared x. And what is your dx equal to here? Your dx is equal to dt divided by secant squared x. So your secant squared x and secant squared gets cancelled. Now here you have it as 1 plus t squared divided by t you get. I can just write it as 1 by t plus t squared by t. So here if you see, it gets cancelled here. What is 1 by t? It's nothing but log t, plus you have only t here. So what is integral of t? It's t squared by 2 plus a constant. So here I'll have to substitute again t. So what will I get? Log of tan x plus tan squared x by 2 plus a constant. Yes. Yes. So the 20th question, you have integral of cos 2x divided by cos x plus sin x the whole squared. Okay. So here in this case, I need to write cos 2x in terms of cos x and sin x. Okay. So here if you see, this is an identity we haven't used so far. It's nothing but your cos 2x is equal to cos squared x minus sin squared x. This is the formula you get. So it is cos squared x minus sin squared x you have. So your I equal to integral of, this can be written as cos squared x minus sin squared x divided by cos x plus sin x the whole squared. Now here if you see, you have got it as a squared minus b squared, because you have cos x plus sin x, there are chances for us to cancel it actually here. So I will write it as cos x plus sin x into cos x minus sin x. So what happens here? It gets cancelled. You are left with integral of cos x minus sin x divided by cos x plus sin x. Now can you tell me what is the method I will be using here? Yes, I already told you, if you have a rational function like this, see when you differentiate the numerator whether you get the denominator, you get the numerator. Differentiation of cos x, what is it? It's minus sin x plus differentiation of sin x. What is that equal to here? It is cos x. Have you got the numerator here? Yes. So I can put t is equal to cos x plus sin x. dt by dx is equal to minus sin x plus cos x you have here. So what is your dx equal to there? It's dt divided by cos x minus sin x. This is what you have here. So what is your I equal to there? I is equal to integral of cos x minus sin x divided by t into your dt divided by, okay, so here your dt divided by cos x minus sin x. So again it gets cancelled. So it's just 1 by t into dt. So what is integral of 1 by x there? You know that it is equal to log x, you know here. So I'll write it as log t plus a constant. So what's the value of t here? T is equal to cos x plus sin x. Okay, so I can write the answer as log of cos x plus sin x plus a constant. You understood? So again I'm telling you, the identities are very important here. So we'll be using the same identity in different forms actually here in different questions. Got it? Yes. Now we'll go over to the 21st question. Integral of sine inverse of cos x. So here if you have an inverse and you have a cos here, if I write this in terms of sine, it is easy for me. So I can write this as sine of pi by 2 minus 6. That's all. Sine inverse and sine, it gets cancelled here. You're left with pi by 2 minus x dx. Now when you integrate this, you will have it as pi x by 2 minus x squared by 2 plus a constant. The 22nd question. It's integral of 1 by cos of x minus a into cos of x minus b dx. Okay, so here from this entire exercise, I can say it's a slightly different one actually here. So because there is no way for us to substitute, nor we cannot apply the formula also directly here, because 1 by cos is nothing but secant into secant you will get. Even this function is of the same, the angle is of the same type, no problem for me. That is also different. You have it as x minus a into x minus b here. So in order to bring in this a and b, what I'm going to do here is I'm going to multiply by sine of a minus b. Why is that I can multiply by sine of a minus b here actually here? If you see in this case, if you sine of a minus b is nothing but a constant, because a is also a constant, b is also a constant here. So I'm going to just multiply and divide by sine of a minus b. So what will I have now? I equal to 1 by sine of a minus b into sine of a minus b by cos of x minus a into cos of x minus b dx, integral of this. So here, since it's a constant, I have taken this 1 by outside the integral. Okay, so your first step is over. Now, okay, so here again, in this case again I cannot apply, because here I have x and here also I have x. So I need to introduce x here. So how can I introduce x? That's what I have done in the next step. 1 by sine of a minus b, integral of sine of x plus x and minus x plus a minus b divided by cos of x minus a into cos of x minus b dx you have here. Okay, so in order to apply the formula, you have it as 1 by sine of a minus b integral of, I'll just take these two together because I need x minus b. Okay, so x minus b. Now here when I take the minus sign outside, you're left with x minus a. Okay, so I've just rewritten it as x minus a and x minus b. Now what formula is it follow actually here? Sine of a minus b. Your a is nothing but x minus b and this is nothing but equal to b. So what's the formula I can write here? It is sine a cos b minus cos a sine b. This is the formula you have here. So here I've written it already. So it's 1 by sine of a minus b you get here. So it's integral of, when I use the formula, what will I get? Sine of x minus b into cos b. What is it? Cos of x minus a minus cos a. What is cos a? Cos of x minus b into sine of x minus a divided by cos of x minus a into cos of x minus b dx. This is what I have done here. Got it? Now we'll just split it as two separate here. So 1 by sine of a minus b, this is one function you get here. Sine of x minus b into cos of x minus a divided by cos of x minus a into cos of x minus b dx minus, this one is different here. So what will I write? Integral of cos of x minus b into sine of x minus a divided by cos of x minus a into cos of x minus b dx. This is what you have here. So here if you see, it gets cancelled. Here if you see, this gets cancelled. So you are left with what integrand here? 1 by sine of a minus b integral of this one, sine of x by x minus b by cos of x minus b dx minus 1 by sine of a minus b integral of sine of x minus a by cos of x minus a dx. Now you have brought it to the, here in this case you have brought it to the simple form where you can integrate it. How can you integrate it? The differentiation of the denominator will give you the numerator. Am I right here? So I have just taken both here. Okay, since you have two substitution, I have done it simultaneously. Put t is equal to cos of x minus b. If you want, you just put this as t1 or something like that here if it's confusing. But I have just taken both to be t. dt by dx is equal to minus sine of x minus b. Your dx is equal to minus dt divided by sine of x minus b. The same way here also, you get t equal to cos of x minus a, dt by dx is equal to minus sine of x minus a you get here. So what is your dx equal to there? It's minus dt divided by sine of x minus a. So here we have it as I equal to 1 by sine of a minus b integral of, I have just substituted there, sine of x minus b by t into minus dt divided by sine of x minus b minus 1 by sine of a minus b integral of sine of x minus a divided by t into minus dt by sine of x minus a. So here if you see, it gets cancelled. This also gets cancelled here. So you can take 1 by sine of a minus b common, put a bracket here. It's minus integral of dt by t plus integral of dt by t, because minus minus it becomes plus. So you have it as 1 by sine of a minus b. This is nothing but minus log t. This is nothing but plus log t. Don't cancel it by mistake. That's why I told you, if you want you can just take this as t1. If you want you can take it here. So what is this t? It's nothing but 1 by sine of a minus b into minus log of cos of x minus b plus log of cos of x minus a plus a constant. So here we can just write this by using the logarithmic rule. You can write it as log a minus log b. So what will I get here? Log cos of x minus a by, what will I get here? Cos of x minus b plus a constant. This is optional here, so plus a constant. Log a minus log b is nothing but log of a by b.